Hello fellow math, I am Dr. Vilva and meet my friend Brinda.
Hi, you just found me in UK, that is unknown to known channel. Here, numbers stop being scary and start to say story. Let us involve, learn and win.
Today we are diving into chapter 2, polynomials. We are going to revisit the core concepts, learn how to find the zeros of a polynomial, uncover the secret behind their geometrical meaning and its need. That is, why to know about polynomial. What is a polynomial? Let us start with the basics. Look at these expressions: 2x, x square plus 2x, x cube minus x square plus 4x plus 7. These are what we call polynomials in one variable. Think of a polynomial as an expression made up of terms like x square or 4x added up or subtracted together. What is a key rule? The variables only have whole number exponents. We will see some examples. In first example, 2x. Here, the exponent is 1. Our second example is x square plus 2x. The exponents are 2 and 1. Third example, the exponents are 3, 2, 1, and for constant we can write it as 7 times x power 0. Therefore, exponent is 0. Here, all the exponents are whole numbers. Look at these examples. If the exponents are 2 by 3, 1 by 3, 3 by 2, etc., then they are not a polynomial. Now, when we talk about this mathematically, we give them some name. We use function notation instead of just writing the expression. We will write it as p of x. See here, p of x equal to 2x. P of x equal to x square plus 2x. P of x equal to x cube minus x square plus 4x plus 7. By writing p of x, we are simply telling the reader this is a polynomial and the variable inside it is x. Here is a common point of confusion. Polynomials aren't restricted to just using the letter x. You can use any variables you like. The notation just adjusts to match. For example, we can write a polynomial in the letter t. P of t is equal to t power 5 plus 2t. P of y is equal to 3y cube minus 5y square plus 2 is a polynomial in y. You can have a polynomial in u. See the pattern here. Whatever letter is inside the parenthesis, that is t, y, u, is the variable that makes up the entire expression. Okay, we have got the basics down. But what about those weird cases where there is no variable at all? Let us talk about the constants. Sometimes you will see something just like a plain number like 2, minus 5 or 7. Believe it or not, these are actually polynomials. We call them constant polynomials. Think of it like this. The variable is just hiding or it has a power of 0. Consider 2. It can be written as 2 times x power 0. And we know that x power 0 is 1. Another special case where the polynomial is just 0. We call that the zero polynomial. Now we will see degree. Now, how do we measure the strength of a polynomial? We use something called the degree. The degree is simply the highest power of the variable in the expression. Let us look at this table. Did you see that? If you have 5x cube, the power is 3, which is the greatest power in the expression. So, the degree is 3. Similarly, second example, we have x power 8. The degree is 8. You just scan the expression, find the biggest exponent and boom, that's your degree. For constant, the degree is 0. Are you ready to take polynomial game to the next level? We have got the basics down. So, let us dive into the next level. Terms, coefficients and the cool visual secret behind zeros. First, let us break down the structure. If you have an expression like 5x cube plus 4x square minus 5, it is made of terms. 5x cube is the first term, 4x square is the second and minus root 5 is the constant term. Now the numbers multiplying your variables are coefficients. For square root 5x cube minus 4x square plus 6, the coefficient of x cube is root 5 and the coefficient of x square is minus 4. If a power is missing, like x power 1, x is not present in the expression, its coefficient is 0. We name polynomials by their degree, which is just the highest power of the variable. Degree 1 is a linear polynomial. For example, 4u minus 2. When degree is 2, it is a quadratic polynomial. The word quadrate means square in Latin. Example, 5x square minus 4x minus root 5. When degree is 3, it is a cubic polynomial. Anything with a degree 1 is a linear polynomial and the degree greater than 1 is simply a nonlinear polynomial. Also, watch out. If you see a variable in the denominator, 1 by x, in the denominator, if we have x or under a square root, that is not a polynomial. Here I have given a general form of a polynomial. In this equation, an should not be 0. If an is not 0, then highest power of x is n. Therefore, here degree is n. Also, a0, a1, a2, etc. are all constants. Now you all know what is p of x. Now we will find p of 2. For example, p of x is x cube minus 2x square plus 6. We have to find p of 2. Just plug in 2 for every x. We will get p of 2 is equal to 2 cube. I just replaced x as 2 minus 2 times 2 to the power 2 plus 6. If you simplify this, we'll get some constant which is 6 in this case. Similarly, you can find p of minus 1. Just replace x with minus 1. We will get some answer. Why is this so important? To answer this question, we will see what is a zero of a polynomial. It is simply the value that makes the whole polynomial equal to 0. Consider p of u equal to 2u minus 3. What is 0 of a polynomial? It should be equal to 0. Therefore, p of u equal to 0. What is p of u? 2u minus 3. Therefore, 2u minus 3 equal to 0. Shifting minus 3 to other side, 2u equal to 3. If you simplify, u is 3 by 2. If you substitute u as 3 by 2, that is p of 3 by 2 will be 0. For a linear polynomial ax plus b, just set it to 0. We will get x equal to minus b by a. That is negative constant term divided by coefficient of x. This is the general form. Why do we care about zeros? The answer is simple. They have a geometrical meaning. Think about a linear polynomial p of x equal to ax plus b. When you graph this, it is always a straight line. If you want to find the zero, you are basically asking where does this line cross the x-axis. The previous example, u is 3 by 2, which is 1.5. Let us see the graph. If we graph a linear polynomial, it is a straight line that hits the x-axis exactly once. The x-coordinate of that intersection is the 0. It is exactly at 1.5. Things get even more interesting with quadratic polynomials where the degree is 2. Instead of a straight line, these create a curve often called a parabola. Notice how this curve can cross the x-axis at two different points. Those are our zeros. Depending on the equation, a quadratic can have two zeros, 1 0, or sometimes no zeros at all if it never touches the x-axis. Look at this example. U-shaped parabola we got, and it passes through the x-axis at minus 3, 0 and 0.5, 0. Look at the coefficient as x square. It is 2. If the coefficient of x square is negative, we will get inverted parabola like this, and the zeros are at 1 and 1.5 for this equation. Depending on the equation, a cubic equation can have 3 zeros, 2 zeros, 1 zero, or sometimes no zeros at all if it never touches the x-axis. In this example, we have 3 zeros, one at -2, other at 0, and the third one is at 2.
Why to study polynomials, Vilva? And why these polynomials are so important? If it is not having some application, we will skip this topic.
Vrinda, every mathematical concept have its own use. Here I will mention a few for polynomials. If you throw a ball, launch a rocket, or even just drive a car, its position changes over time. We use polynomials to describe these paths. The path of a ball thrown into the air follows a curve that can be perfectly modeled by a quadratic polynomial. Engineers use these equations to predict exactly where a projectile will land. When designing airplanes or car bodies, engineers use polynomials to create smooth, curved surface that reduce air resistance and increase fuel efficiency. We will do some exercise problems now. Before that, if this video helped you to visualize math, give it a thumbs up and subscribe for more. What did you learn from this video? Finding a zero of a polynomial is the same thing as finding the x-intercepts on a graph. The number of times our graph hits the x-axis tells us exactly how many zeros that polynomial has. It is essential to remember this rule. The number of zeros is determined only by the number of times the graph intersects or touches the x-axis. In our first example, we have 1 0 because the graph intersects the x-axis exactly once. Now, look at this second example. The number of zeros is still just 1. Don't make the mistake of counting the y-intercept. Always focus on the x-axis, not the y-axis. You have mastered the basics of polynomials from naming them to understanding their geometry. In our next video, we will discuss relationship between zeros and coefficient of polynomial. Thanks for watching. Let us involve, learn and win for sure.